Pick up almost any object, a pen, a spoon, a stone. Without thinking, you will probably reach for it with your right hand. Roughly 9 out of 10 humans do the same. It does not matter where they live, what language they speak, or how they were raised. Across the planet, the right hand dominates. That is strange. Many animals prefer one paw, claw, or side of the body. But humans show something far more extreme. Almost our entire species leans in the same direction. Why? Is the right hand stronger? Did ancient people simply copy one another? Or did something happen inside the human brain long before civilization began? The first clue was not found in a brain. It was found on ancient teeth. How can archaeologists know which hand someone used tens of thousands of years ago? The answer begins with a strange habit. Ancient humans often used their teeth like a third hand. They held animal hide, meat, or plant fibers between their front teeth. Then they pulled the material tight, cut it with a stone tool. Sometimes the blade slipped. It scraped across the teeth, leaving tiny diagonal marks in the enamel. Those scratches remained long after the person died, and their direction reveals which hand held the blade. A right-handed person usually pulls the tool across the teeth at one angle. A left-handed person cuts from the opposite direction. Researchers have found these marks on Neanderthal teeth. Most point to right-handed movements. The same pattern appears in arm bones. One shoulder may be stronger. One arm shows more evidence of repeated strain. Together, the clues reveal something remarkable. Right-handedness did not begin with writing. It did not begin with farming. It existed among other kinds of humans, long before our species was the only one left. But that creates a deeper mystery. Why would evolution push so many individuals toward the same side? To make a stone tool, both hands are needed. One holds the stone steady, the other strikes it. But the jobs are not equal. The supporting hand controls position. The striking hand controls speed, force, and precision. Switch the roles, and the movement suddenly feels wrong. Over thousands of repetitions, the brain becomes better at assigning each hand a specialty. One hand stabilizes. The other performs the most precise action. For most humans, the right hand became the specialist. This may have mattered more as tools grew complicated. Breaking a random sharp flake from a stone is one thing. Shaping a balanced hand axe requires planning. The maker must choose the striking point, predict how the rock will fracture, and repeat the movement with remarkable control. A shared hand preference may also have made these skills easier to teach. A child watching a right-handed toolmaker could copy the movements directly. The same grip, the same angle, the same sequence of strikes. If most people worked in a similar way, knowledge moved through the group more efficiently. Tools could be passed between people. Techniques became easier to demonstrate. Cooperation gained a common pattern. Perhaps right-handedness did not spread because the right hand was naturally superior. Perhaps it spread because groups benefited when most people organized complex movements in the same way. But tools may explain only half the story, because the part of the brain controlling the right hand also became famous for something far more powerful. The left side of the brain controls most movements on the right side of the body. In most people, the left hemisphere is also heavily involved in language. That connection has fascinated scientists for generations, making a tool and speaking seem completely different. One shapes stone, the other shapes sound. But both require actions to happen in the correct order. A hand axe cannot be made with random strikes. A sentence cannot be understood if its sounds are placed randomly. Each depends on sequence, timing, and precise control. Brain imaging research suggests that tool use and language rely on partly connected networks. This does not prove that one created the other. Language did not simply appear because someone made a stone tool. And left-handed people do not have language on the wrong side of the brain. The relationship is much more complicated. Still, our ancestors may have benefited from concentrating difficult tasks in one hemisphere. The left side became increasingly specialized for rapid sequences. The right hand handled precise actions. Language later used some of the same organizational machinery. Perhaps the dominance of the right hand was not a separate human feature. It was part of a much larger transformation, in which the two halves of the brain began dividing their work. One side became especially skilled at controlling sequences. The other focused more on space, attention, and the larger picture. Dividing the work made the brain more efficient. But it still does not explain everything. If right-handedness helped with tools, teaching, and perhaps language, why did evolution stop at 9 out of 10? Why did it not make everyone right-handed? The answer may be hiding in the advantages of being different. If using the same hand made cooperation easier, left-handedness should have disappeared. But it did not. And the reason may be competition. Most right-handed people grow up watching right-handed movements. They learn to predict where a punch will come from, how an opponent will swing, and which direction a weapon will move. Then they face a left-hander. Everything is reversed. The angle feels unfamiliar. The timing is harder to read. The attack comes from the side they have practiced against least. This may explain why left-handers are often unusually common in certain interactive sports. Boxing, fencing, table tennis, cricket. The advantage is not that left-handers are naturally faster or stronger. It may come from rarity. A left-hander regularly competes against right-handers. A right-hander rarely competes against left-handers. One side receives constant practice. The other receives a surprise. Scientists call this negative frequency-dependent selection. A rare trait can remain useful precisely because it is rare. If half the population became left-handed, the surprise would disappear. This creates an extraordinary balance. Cooperation favors a shared preference. Competition rewards the minority that breaks it. Perhaps evolution never intended to eliminate left-handedness. It kept just enough variation to prevent the system from becoming completely predictable. But human societies did not always appreciate that difference. For centuries, many tried to erase it. Once writing became important, the right-handed majority began designing the world around itself. Tools were shaped for the right hand. Writing systems were taught by right-handed teachers. Everyday customs turned one side into the proper side, and the other into the wrong one. In many schools, left-handed children were forced to write with their right hand. Some were punished. Others were told that their natural preference was dirty, unlucky, or even dangerous. The language remembered this prejudice. The Latin word for left was sinister. Over time, the same word came to mean threatening or evil. Cultural pressure became so strong that older generations often reported far fewer left-handed writers than younger ones. But when researchers looked beyond handwriting, the pattern became clearer. Many people who had been trained to write with the right hand still preferred the left for throwing, cutting, or performing other precise tasks. Society could change the hand holding the pen. It could not always change the preference inside the brain. When schools stopped forcing children to switch, the number of openly left-handed people rose. Left-handedness had not suddenly evolved again. It had simply stopped hiding. That reveals something important. Handedness is not only imitation. Children do not become right-handed just because they see adults using that hand. Biology matters. There is no single right-handed gene. Instead, many genes and early developmental processes influence how the brain organizes movement. Culture can push that preference. Training can modify it, but neither can fully control it. There is one more group that makes this story even stranger. A very small number of people can use both hands almost equally well. They are called ambidextrous. At first, that sounds like the perfect evolutionary advantage. Why choose one hand when you can use both? But true ambidexterity is surprisingly rare. Researchers estimate that only about 1% of people naturally show this ability. If using either hand were always better, you might expect evolution to favor it. Instead, it did the opposite. Why? One possible answer lies inside the brain. Specialization makes complex tasks faster. Rather than asking both hemispheres to do the same job, the brain often divides the workload. Brain scans suggest that naturally ambidextrous people often show less lateralization for some functions than strongly right-handed individuals. That doesn't make their brains better or worse, just organized a little differently. A brain where every task is shared equally may sound flexible, but it is not necessarily more efficient. In other words, our brains may perform best, not when both sides do everything, but when each side becomes exceptionally good at something. That is why true ambidexterity remains so uncommon. Evolution didn't build the most symmetrical brain. It built the most efficient one. And for most humans, that meant choosing a side. Right-handedness may have spread because standardization made cooperation easier. People could demonstrate tools in similar ways, share equipment, coordinate work, and pass difficult movements from one generation to the next. But a completely uniform population would lose something: unpredictability. In direct competition, the unusual movement could become an advantage. So human-handedness may reflect a balance between two opposing forces. Cooperation pushes us towards sameness. Competition preserves difference. That may be why right-handedness became dominant, without ever becoming universal. The right hand became the standard. The left hand survived as the exception. And the exception remained useful because it never became common. Pick up a pen, a spoon, or a stone. The hand you choose may feel like a tiny personal habit, but it carries a history older than writing, older than farming, and possibly older than our own species. Ancient teeth reveal which hand held a stone blade. Tools show how the brain divided complex work. Language may have strengthened that division. Cooperation turned one preference into a shared standard. Competition kept the opposite one alive. So humans did not become right-handed because the right hand was simply better. We became a mostly right-handed species, because groups benefit when people follow the same pattern. But evolution rarely removes every alternative. Sometimes, being different is the advantage, and perhaps that is why the world still has left-handers. Not because evolution failed to finish the job, but because the job was never to make us all the same.